We use it every single second of every day. But have you ever stopped to wonder how the internet actually works? I mean, really works? The answer is pretty wild. It involves thousands of miles of cables under the ocean, a phone book for the entire globe, and a journey that happens at pretty much the speed of light. So let's dive in. Okay, so let's be honest for a second. When you think of the internet, what do you actually picture in your head? Is it, a big fluffy cloud? Or maybe you just imagine Wi-Fi signals magically beaming around the planet. It's a super common image, right? This idea that all our data lives in some invisible, wireless world. But here's the thing. That mental picture is almost completely wrong. The reality is so much more tangible and honestly way more incredible. The internet isn't some cloud floating above our heads. Nope. For the most part, it's a massive, sprawling network of actual, physical cables buried under our feet and stretched across the deepest parts of the ocean. That's right. The internet is a physical thing. It's a global system of computer networks all hooked together. And yeah, some of those connections are wireless, like your Wi-Fi. But the vast, vast majority of data, especially the stuff going between continents, it's all traveling through millions of kilometers of fiber optic cables laid on the ocean floor. That is the real World Wide Web, a literal web of glass connecting the entire planet. So when you click on a link or search for something, your request doesn't just, float off into space. It starts an incredibly fast physical journey. Let's break down exactly what happens in that very first millisecond. The secret sauce to the whole thing is a brilliant concept from the 1960s called packet switching. Instead of trying to send a huge file, like a photo, all in one go, the internet does something way smarter. It breaks it down into thousands of tiny, easy-to-manage pieces called packets. You can think of it like taking a giant picture, cutting it into a bunch of postcard-sized puzzle pieces, and then mailing each piece on its own. And this process is ridiculously efficient. The second you hit enter, your computer just chops up your request into all these little data packets. Each one gets its own digital address label, telling it exactly where it needs to end up. And then, whoosh, they're all sent out into the network, often taking completely different routes to get to the very same place. Which, of course, brings up a really important question. How do these millions and millions of packets, all zipping around the globe at the same time, actually know where to go? I mean, how do they find the one right computer out of billions? Well, this is where a super important translation has to happen. See, we humans are good with names, like wikipedia.org, but computers, they only really get numbers. Every single device connected to the internet has its own unique numerical address, called an IP address. So to make it all work, you need something that can translate between the two. And that translator is called the Domain Name System, or DNS. The best way to think about it is like the internet's gigantic global phone book. When you type a website name into your browser, your computer does a lightning-fast DNS lookup to find the matching IP address. It's just like looking up your friend's name in your contacts to find their street address. So who's in charge of this massive phone book to make sure there are no duplicates or mistakes? That huge job falls to a nonprofit group called ICANN. They're the ones who coordinate the whole system of names and numbers, making sure that when you type in a web address, you actually get to the right place. They're totally essential for making sure the internet works as one single global network. Okay, so quick recap. Our packets are all broken down and they have an address. Now for the really incredible part, the journey itself. This is where things get mind-bendingly fast. The main players in this journey are millions of special computers called routers. Just think of them as hyper-efficient postal workers. A router grabs a packet, instantly reads the IP address on it, and then forwards it to the next router along the path toward its final destination. It's like a massive global relay race happening over and over at almost the speed of light. Now, this journey isn't just random. It actually moves up a kind of hierarchy. From your home network, your packets go to your internet service provider, your ISP. Then your ISP connects to even bigger regional networks, which in turn connect to the absolute backbone of the entire internet, these giant Tier 1 networks. These are run by a handful of huge companies that own the actual physical undersea cables that link all the continents together. So after this insane global journey, what happens when all those tiny digital postcards finally get where they're going? And more importantly, what does this all say about the system we rely on for, well, pretty much everything? In just a fraction of a second, all those packets arrive at the destination server, even if they took completely different paths to get there. A final set of rules, called the Transmission Control Protocol, or TCP, acts like the supervisor at the end of the line.
It does a quick head count to make sure every single packet made it, checks for any errors, and then puts them all back together in the perfect order to build the web page right there on your screen. The scale of this system is it's hard to even wrap your head around. To give you some perspective, way back in 2007, the internet was already carrying over 97% of all the information sent by telecommunication. Today, it's become the absolute, undeniable foundation of how we all communicate.
But here's the kicker. For all its size and speed, this physical system has a pretty surprising weakness. In 2011, a single woman in the country of Georgia was just digging for some scrap copper and she accidentally sliced right through a fiber optic cable. And by doing that, she cut off internet access for almost the entire neighboring country of Armenia, for hours. That's just how physical and in some ways how fragile this whole global network really is. So the next time you tap a link, just remember that incredible journey. Your request gets shattered into tiny pieces, it's guided by a global address book, it races through physical cables on the ocean floor, and it's all put back together in milliseconds, just for you. It works flawlessly pretty much every time. Which leaves us with one final thought. What does it mean that our modern world is built on a system that is at once so unbelievably massive and yet so surprisingly fragile?